Hello there, long time no see. It's been a while since I did the last video, so I might be a little bit rusty in the ways of the game, but I'm sure I'll pick it back up. I'm going to start this video in a separate file anyway, because I want to cover some functions, because really all we've used them for so far, if we have a look, is to respond to event listeners, which is totally fine, that's what you're meant to do, but functions are so much more than that. You can customize them yourself, have special functions that just do little bits for you, save you time, have reusable code inside them that you can just quickly access. So we're going to have a look at that. This is actually the second time I made this video. I just did it, 30 minutes long it was, and I realised the microphone was off at the end. I was absolutely gutted. It went well as well. So let's hope I can do it somewhat similar. So in this new file, just going to script into the first keyframe and make a basic function. And we know how to do that, we've done that before. Put the word function, give it a name, let's call it test. Open brackets, close brackets, open your curly braces. Now normally we'd have something in these brackets because we're responding to event listeners most of the time. They're known as arguments, and we'll cover them in a little bit, but what we can do in here, if we have this function and we just tell it to trace hi and run the program, you'll see that we don't get anything. And that's because we haven't actually made any use of this function. In the videos so far, the event listeners have used or called the functions for us. So from now on I'm going to call it calling a function. So we need to call this function, and to do it we just type its name and the brackets, and now test it. And we can see that we get the word hi traced out. Just run that again so I can close the window properly. So by making a function and then typing its name, we actively call it. And now the arrangement of this doesn't really matter. You don't have to make the function above it in the keyframe, as long as it exists in the file. I would recommend having your functions before you use them though, because if it hasn't loaded a frame or it just doesn't know where the function is, you're going to have problems. So I'd say put the functions up at the top and use them below. What we'll eventually do is put these functions into static classes, which I'll probably cover in the next video. They won't all be static. You probably don't even know what the word static means just yet. It's not the stuff that sticks balloons to the roof. It has a use in programming. Let's get back on track, eh, Anthony? Stop waffling. This function, we're going to provide it with some information now. So we're going to use the space between the brackets here, because at the moment we're just tracing out the word hi. Let's give it something to trace out. So if we pass some information in, I'm going to use the word s for string, and we need to tell it that this information is going to be a string. So we'll use a colon and type string. Just as we would with a variable to tell it what type to be, we've told test here that we want to use an argument called s, and it's going to be a string. So now we can trace out something different. If we trace you said plus s, test it now, we'll still get an error. And that's because this function was expecting an argument and it didn't get any. So it's told us here that we've provided an incorrect number of arguments. And that's because where we've called it here, we haven't given it the information it wants. So it's expecting a string, and we haven't provided it with one. So let's type something in. Let's say hi again. Test that. And now we can see that it's tracing out you said hi. It's taken the information we've given it and traced out you said plus that piece of information. Now what you can do is set a default value for your argument. So if I delete the hi there and just put equals after the string and put default, actually we'll use nothing because that makes sense. So by default this argument is set to nothing, and if we test it now we can see you said nothing. But if we come back and put our own bit of information, if we put something and test it, it changes. So instead of saying nothing, we've said something. So it's good to protect against any potential errors by having a default value. You'll get the errors if you don't do something right anyway, but it's always good to know that you're backed up. Don't know why I deleted that. Let's put that back in. What you can also do is tell a function to give you some information back. And to do that, you use the word return. So instead of tracing this out, we'll return you said plus s. Let's get rid of that bracket. Try it now. We won't get anything again. And that's because we haven't made any use of this information. It's just returned to us. So we'll trace out the function. If we just trace the whole function with the piece of information, we can see that you said something. What we haven't done that we should have done is tell this function that it's going to return something. Because if we don't return something, it can then tell us that it was expecting to. I'll show you what I mean. If I come up here and tell this function to return something, so we put a colon, which again dictates the type of information to return. We tell it to return a string, and then don't return a string. If I comment that out, we can see that the function does not return a value pops up as an error. And that's because we told it here in the declaration, we said we want this function to return a string, and then we didn't actually return one, and it's just flagging that up. So if we now return it, it'll be happy, and it'll tell us that we said something, which is all good. Let's see, how can we advance this a bit further? If we return something that wasn't expected, so if I put the number 10 here and run it, we can see that it's been given an int, it's been given a full number when it was expecting a string. So it wasn't happy about it. And that's useful again for flagging up any problems. It's good to know when you make a mistake in your code. And by giving Flash all this extra information, you can safeguard against those problems. So we're going to return what we had before. Let's just undo it. In fact, let's change it. Let's pass in a number this time. We'll pass in two numbers. So test is now going to take n1, which will be a number. And to tell it we want another piece of information, we use a comma. So we're going to put comma n2 number. And let's say we're going to add them together, so we'll return a number as well. So we're no longer returning this piece of string, we're going to return n1 plus n2. And we'll get an error here if we run it, because it's expecting a number and we've given it a string. And we also haven't given it enough information. So not only did we give it wrong information, we didn't give enough information. It's expecting two arguments and we've only given it one. So let's correct that now. We'll give it the number 2 and the number 3 separated by a comma. And run that. So we now get the answer 5, which for anyone not familiar with life is the sum of 2 and 3. So 2 plus 3 is 5 for future reference. What we can also do now that we're set up here, we can use this lots of times. So we could, I don't know, let's copy it, and instead of having 2 plus 3, we could have, oh, I just copied again, paste it, we can have the sum of 2 plus 3 plus 3. So we're adding 3 to 5 effectively. Run that and we get 8. We could copy this, paste it underneath. Let's just trim it down a bit so we're only having 1 extra. And let's say here we could have 5 and 13. So we'll be tracing out 2 things this time. Same function used, but by providing different arguments we get different results. Now this is all dead boring. This is no real use in games, this sort of function. No one's going to trace stuff out, so let's make something a bit more worthwhile. So I'm going to go to my stage here and I'm going to draw a little circle to use. Convert it to a symbol. Just right click on it, make it a symbol, make it a movie clip, press OK. And I'm just going to duplicate it by holding the Alt button and dragging a bunch of them around the screen. Try to put them in random locations because we're going to make a function to arrange them. So the messier, the better, so we can see that it's actually arranging them. Go back to my script, make sure I'm working on frame 1. So timeline, click frame 1. And we're just going to make a quick array to hold all of these things. So we've already covered arrays. We're going to use a for loop as well, so make sure you're familiar with those. So we'll put var ARR, pirates array. It's going to be a type array, and it's going to be a new array. Then we're going to loop through all the children of the stage and add them to this array. So we'll use var I equals 0, I for integer. I is less than num children, which is the total number of children on the screen. I++, so I gets one bigger after every loop through this section. And we're just going to take the child at the position of I and add it to our list. So I'm doing loads of hand gestures here, they're totally pointless. We'll do r.push get child at I. And then just to check that we've got stuff there, we'll trace the array's contents. And you can see here that we've traced out a bunch of movie clips, so it has actually got them and put them all in the array, so that's good. We can assume that's working. Let's now make a function to arrange them. So I'm going to make a function called arrange and open the brackets, open the curly brackets, and get going. Now let's say this arrange function is going to take a property of type array. So we'll go here, put an argument, we'll use the letter A, and it's going to be of type array. It's not going to return anything at the moment, but it's going to do something. So let's have a for loop in here. We'll use a different variable name this time, var h equals 0. H is less than a dot length, because we've passed a in, so we're now using a instead of r. R will still work, but we're making this reusable by using the name that we've given it here. And h++. So that's the for loop setup, and I'm just going to arrange them in a straight line for now. So we'll say a square bracket h dot x equals 100. So it's going to start at 100 plus open brackets h times 20. So starting from position 100 and then adding 20 for each one in the list. So this should be separated by 20 pixels. And then a square bracket h can just, dot y can just be 200. So we'll set that as a constant. Test that, hopefully it'll work. No, it won't, because we haven't called the function. Woohoo! So we need to call the function that we just made. Let's say arrange, open brackets, r. And there we go, it arranges them for us. So far so good. The beauty of functions that we've already covered is that you can give them information and they'll react to it. So instead of having these static values of 100 and 200, let's give it something to work with. So let's add 2 extra arguments. We'll have sx, starting x, as a number, and we'll have sy as a number, so the starting y as well. And instead of using 100 and 200, we'll have sx and sy. Test it, we'll get an error because the function's expecting 3 arguments and we haven't provided them. So down here we need to update. We'll put, let's move it just for effect so you can see that it's different. We'll do 200 and 300, test that. We get a line of pieces starting from 200 along, 300 down, so that's working. And what we could have done here is set default values for these. So we could have put sx by default is 100, sy by default is 200. And just as a point of note, any arguments that take a default value have to come after the arguments that don't. Because if this was at the end, and then we just called the function, like we're going to do here, say we delete that, there's no way of telling it what this array will be without also telling it what these would have been. So the fact that they have a default value is pointless if this array was at the end. So default values have to go after anything that doesn't have a default value. Try that, and you can see it's gone back to its original position because it's using those defaults, those 100 and 200, which is good. I'm going to take it a step further by using functions inside functions, I think. So what we'll do is we'll add an extra property for the type of arrangement to do. So here we'll have a type, make it a string, and by default it'll be line. Because that's what we've already got here. I'm going to cut this out and I'm going to put arrange line a comma sx comma sy. So this function is now using another function which we need to make. Function arrange line, and that's taking a array sx number sy number, and we'll just paste the code. Just check it works before we advance it a bit further. It still works fine. Now the reason I've done that, you might think, what was the point? It's because I want to also have a circular arrangement, and I just want to keep the code nice and clean. So this function, this arrange function, can take lines or it can take circles, which I haven't done yet. So let's say here, if type equals line, which is the default, so by default it will do a line. If type is line, we want to arrange line. However, if type equals circle, we want to arrange circle. And we'll pass the same again, a, sx, sy. We need to make that function now. So, a bit of maths involved, but not to worry, let's do it. Function arrange circle takes a, which is an array, sx, which is a number, and sy, which is also a number. And we're just going to arrange any elements of this array in a circle around this point. So we'll just copy the for loops, might as well. So we've got the for loop, and the positioning is just going to be slightly different. This is where the maths kicks in. So a h dot x is going to be sx plus math. We need a distance there, so we'll do 30. No, make it bigger. That's the radius of the circle, which we could have passed in as an argument if we wanted to. 60 times math.cos, bit of trigonometry, and then we want h times, and then in brackets we'll have 2 times math.pi. This is because we're working in radians. 2 times math.pi is a full circle in radians, so 2 pi is one circle, 360 degrees, and we'll divide that by a dot length. So we're splitting a full circle into the amount of elements in the array, and then we're timesing it by h, which is the current element we're looking at, so we should get a decent segment of circle there. If that doesn't make sense to you as I'm typing it, it'll make sense when you see it on screen. ah.y is the same, but using sy and sine instead of cos. So 60 times math.sin. H, I should have copied and pasted, but oh well, I've started so I'll finish. Math.pi slash a.length. Bracket, bracket. Now, hopefully, if we call arrange past the array and then tell it to be of type circle instead, this function will be called, and it'll say, is type line? No, it's not. And then it'll say, is type circle? Yes, it is. So we'll call arrange circle, and we'll pass the array, we'll pass the starting x and the starting y, and then this arrange circle will happen. So let's try it. fingers crossed. Didn't like array. Oh, because I put 3 R's in it like you do. Array. Woohoo! We have a nicely organised few bits. Let's see, what else can we do there? I didn't like where it was positioned. Let's centre it. So 225. Default size of a flash screen is 550 by 400, so that's half them. Test that. Is that in the middle? It's not, is it? What have I done wrong? Who cares? It worked. It made a circle. Probably my maths. Unless the pivot point of these isn't centred, I don't know. I'm going to look at it again and then I'll forget we ever did it. 275, idiot, not 225. Sorry, it's been a long day. There we go, nice and centred. So that's functions in a slightly huge nutshell, but we had to cover that before we advance the game. So let's jump into the game and do something with them. Because that's what you all came for. You didn't come to hear me waffle about nothing. You want to make a game. Let's do it. What I did promise in the last video was that I'd rearrange these for loops to count down, which I didn't actually do. So let's do that now. So the bullet array here, the bullet for loop, counts from 0 up to bullets.length, but we want to count from bullets.length minus 1 down to and including 0. So let's say bcount is greater than or equal to 0. And instead of bcount plus plus, we use bcount minus minus. And then because we use this for loop twice, I'm going to copy it, paste it in down here, so this one's identical. And do the same to the ship one as well. So let's say count equals ships.length minus 1. Count is greater than or equal to 0. Count minus minus. Save it, test it, hope it works. I'm testing the wrong file. Wally. There we go. Now that would give us errors if we were shooting about 5 bullets at once, or rather it would have given us errors before. We've actually fixed that problem now. So someone did actually mention that to me. So hopefully I fixed it for you there. I'm saying hopefully a lot today. I should be certain. That will fix it for you. Let's go to the ship class now and make some use of these functions we've just spent 7 years learning about. All I want to do before we move on to the next video, because this one's getting very lengthy, the next video will take all the functions we're about to make and blob them into one central class that we can reuse everywhere. So the reason for what we're doing now is so that we can make it reusable. It won't seem that way at first because it'll just look like we're cutting it and pasting it somewhere else. But bear with me, later on it'll make sense. What we're going to do is take all these individual chunks of code and blob them into a function. So for example this one here, where we point the ship at its target, that's a classic example of code that should be a function in its own right. Rather than doing it every time here, I'm going to cut this code and I'm going to replace it with, we'll set the rotation of this ship. Rotation equals face point, and we want the ship to face its target, which is target.x and target.y. So they're the arguments I'm going to pass to this new function we're about to make. So outside of the function update, I'm going to make a new function called face point, and it's going to take fx, we'll say face x, which is a number, and fy, face y, which is also a number. It's not going to return any, oh yes it is, silly boy, it's going to return a number. I'm going to paste what we've got and adjust the maths here. So we no longer have target.x, well we do, but we don't want it for later. We want this to be very generic, so we're going to use fx because it's what we use as an argument, and fy, face x and face y, and then instead of setting the rotation to be angle, we're going to return angle. Save that, test the file. No, we got a problem. Right, we've got a problem there because later on in the code the this hypotenuse uses the dx and the dy that I've just cut out. So as a quick temporary measure, I'm just going to paste those two lines back in. The dx and dy lines, I'll just paste them back in there. We'll get rid of them later. Save it, test it. Everything seems to work as normal. The ships are facing the direction they're travelling, so we can assume that this face point worked. At the moment, it's not the most reusable function because it's still assuming that it's inside the ship class, because here we're using X and Y as the position of the ship, so we will fix that in the next video. Moving on though, we're now going to make a function to move in a direction, so I'm going to cut these two lines, Command X, and I'm going to say move forward, and this function is just going to take the speed of the ship. So we've got a function now called move forward that we need to make. So let's make a function called move forward, and it's taking a speed, s we'll call it, and that's a number. And it's not returning anything to this, so we've not got an equals in front of it. So it doesn't need a return type. It does need us to paste this code in. Again, we're working on the assumption here that this function is inside the ship, which we're going to fix later on. But now instead of using speed here, we're going to use s, because that's the argument we've passed to it. Save it, check that it works. We're not making any gameplay changes at the moment. We need to work on our programming knowledge before we can advance. There's a lot of fairly complicated stuff. I know it's a simple game, but there's some complicated stuff going on, and I do use a lot of functions in the final version, so we need to understand them. Last bit before I call this video is to do this, the distance to. So I'm going to cut that code and we'll put, actually I won't cut it all, just undo that. Yeah, I'll cut it all and just type the two words back in. So I'm going to cut that and I'll put var hip equals, and we'll do distance to, and we want, actually we'll do distance between, we'll make this one very reusable. We'll do distance between, and we'll take two objects. We'll do O1 and O2 when we make the function, but we'll say distance between the target and this. So we want to know the different distance between the ship's target and the ship itself, which is this. So we need a function here that takes two objects, so we'll have O1 of type object. Object is the most generic type of thing. It basically covers anything. Everything extends from an object, which we probably haven't covered. Have we covered extending? I don't know. It's too long since I did a video, but we will do if we haven't. Basically, everything you'll ever make in code is pretty much an object, so you can use that without worrying that it'll mess things up. Anything that goes on the screen will be an object. So it's going to take two objects, O1 and O2, and it's going to return a number, the distance between them. And I'm going to paste in what we cut out. Instead of using target X and X, we're going to use O1.X, O2.X, O2.Y, O1.Y, O2.Y, and then instead of setting var hip to be that, we're going to return this value. So of the three functions we've just made, this one's actually the most reusable because it doesn't make any assumption about the object it's placed inside of. This function is very robust, should we say. It's reusable. It would work in any other location provided they can get to it. So of the three we've made, that's the best one. That's the exemplar. Let's just save it. Saying this, bigging it up, it won't work now. Test it. Yeah, I've typed it wrong. What have I typed wrong? Come on, someone watching, point it out. It'd help if I could see all the errors, I guess. Expected a left paren before the colon. What have I done wrong? Getting too late in the day. Done something wrong somewhere. Someone jump into the video and point it out. Distance between... I haven't given the function a name. Ah, time for bed. There we go, it works. And now it's the best function. That is the best one we've made. Well done, Mr. Distance Between. You are the winningest function. These two we'll correct in the next video, where we take a look at static classes, static functions, which is basically what this maths class is. The math class in Flash has lots of static functions that we can use, like math.squareRoot. We can use that without ever having to make an instance of math, and that's what makes it static, but I'm getting ahead of myself. Let's get this video wrapped up, I'll get it uploaded. Hopefully you understood it. I know we didn't do a great deal to the game, but it's of paramount importance that you do understand functions for future use. So I'm going to leave it at that. Thanks for having patience with me, and I'll see you soon.